into the review now. I feel like we can go ahead and start the review because I know I may have said to go to 6, whatever, 5 or something, whatever, but I think we're ready for the review now. So if you'll go to the print off, I think it's page 50. It's 6.7289. If you don't have this printed off, just kind of write this off. Just get you some white, just a white sheet of paper and follow along as I go. It's not important that you have this exact sheet. What is important is that you get the material written correctly. So I'll try and zoom this in as much as I can so y'all can see all the steps. All right, so here's the deal. They're going to tell us how to solve it at first, and then when we get to the end, you're going to solve it however you feel is best. All right, when we're solving by factoring by grouping, remember the word grouping is we're going to group the first 2 terms and the second 2 terms like that, and then we're going to pull out what's common. All right, so and before we started, if you'll notice, 6, 15, 4, and 10, there is no common factor between all of those. 4 is the one thing that messes everything up here. So I'm going to pull off this in sections and groups of 2. So we're going to pull off a 3 and an X. If you'll notice, there's an X right there with that 15. So that means that we have 2X on the inside and 3. So this is what I get, a factored form of 6x squared plus 15x, okay? I'm sorry, it's 5. Oops. All right, because 3 times 5 is 15, my bad. And then over here, I'm going to pull out a 2, and we are left with 2x plus 5, just like we had a minute ago. And if you'll notice, we've got common terms here and here. This is why factoring by grouping would be best here. Although you could have just combine like terms and use the quadratic formula and all the above. But this is just another way to do it. If you happen to see this cuts out a lot of the extra. And we'll do our little fast trick on this today. All right, so our solutions are, now watch this, negative 2 over 3 and negative 5 over 2, okay? So we'll set 3x plus 2 equal to 0, and we'll set 2x plus 5 equal to 0. And then when you solve this out, you get x is equal to negative 2 over 3, and x is equal to negative 5 over 2. And so there's your 2 solutions. They are rational because they're in fraction form. All right? So now, if you don't have this printed off and you're writing this down, I'll kind of talk about each one for a minute to kind of give you a chance to catch up to where I'm at. But I found these 2 solutions. They're both negative. If you were to graph this, your graph would look like something like this, right? But it would actually be very skinny. It would be like a very slim graph because 2/3 and 5/2 are pretty close to one another. All right, so let's move over to number 2. Solve by the following by factoring. So in this case, it's very much like this, where we factored the terms into 2 binomials here. We're going to do the same thing here and here. So when we solve by factoring, we set up our binomials like this. X times x is x squared. And we think, okay, what multiples of 45 make 4? Well, 9 times 5 is 45, right? So 9 times 5 is 45, but 9 minus 5 makes 4, right? So we're going to get, now let's go over this step. Okay, so if this symbol right here is negative, that means the signs are going to be different. And this symbol right here tells me that the largest number gets a minus sign, okay? So between 9 and 5, the largest number is 9, right? And then there are different signs, so there it is, it's factored now. So when you multiply negative 9 times 5, you get negative 45, x times x is x squared. And then if you do the inner terms, which is negative 9x and 5x, you get negative 4x, okay? And so that's factored form. Now, all we have to do is, by the zero product property, set x minus 9 equals 0, and also set x plus 5 equal to 0. All right, and then now you remember how we did this a minute ago where I said, hey, the answer is negative 2 over 3, and this answer is negative 5 over 2. Well, look, it's the same thing here. Even though you know the answer is going to be 9, but watch this, it's going to be positive 9 over 1. See that? Negative 5 over 1, like that. And so it's very super easy. If you don't even really have to think at this point. If you just use that format, like if you set one side equal to 0 and you use the opposite and then put that over that, it's, hey, easy. Okay, let's go to the next one. Now, obviously, this, if you were to graph that, you don't have to graph this, but if you got 9 and negative 5, so you'd have a graph that looks something like that, right? And how do I know it's facing upward? Is because that a term right there in front of the coefficient in front of your x squared is a positive number. All right, so this one's would face up too, and we're supposed to factor this out. So what we're going to do is you do this by guess and check. That's kind of the idea. We're going to keep trying some things. Now look, the things we don't guess about at all are the 2 and the 1. 2 times 1 is 2, right? There's no other way around that. What I have here is 15. I've got to figure out, okay, what numbers am I going to put here and here to make everything turn out to be 11 in the first place? So let's try. Now I don't want to clutter this up, so we're going to do this in our head the best we can. So what if I put a 3 and a 5 here? If I put 3 and 5 here, what I would have is 2 times 5, which would be 10. And then 3 times 1, which is 3. So 10 and 3 do not make 11, okay? So now instead of putting 3 and 5, let's swap them around. Let's put 5 and 3. All right, 5 here and 3 here. So that's going to be 2 times 3 is 6, and then 5 times 1 is 5. 6 and 5 can make 11, so I'm going to put 5 here and 3 here, x here, because of the x squareds. Now, this symbol means they're going to be the same sign, and then they're both going to be a positive symbol, okay? Make sense? Okay, so now we're going to set that equal to 0 since we factored that out. And look, the answer is negative 2 over 5, and the other answer is negative 1 over 3. I mean, I didn't have to write hardly anything down in order to get the answer there, okay? So now we're going to go through the steps. Set 5x plus 2 equal to 0, and then we're going to set 3x plus 1 equal to 0. And then, so when we solve this out, we get negative 2 over 5. And then in this one right here, we get x equals negative 1 over 3. And so there's my two answers. Negative 1 over 3. Okay, and so done with that. We did that, those two right there by factoring. So the first one we did by grouping. We grouped two sections. This is a trinomial, yes, because this would, actually it's, I don't know, quadnomial or whatever, but I'm not going to get into that. Okay, so let's go down here to number 3. Quadratic formula, easy breezy. All you got to do is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so that's how that works, quadratic formula. All right, now we need to organize this into our a, b, and c. In this term, we got 2, negative 5, and negative 7 for our a, b, and c. Over here, we've got A, B, and C, but A is 5, B is 9, and C is actually positive 7. Because if you were to move this over, if you were to solve this and set this side equal to 0, you'd have to add 7 to both sides, and that's what happens here. And that's why that C is 7. Now let's go throw in our blanks. X equals negative blank plus or minus the square root of blank square minus 4 blank blank. all over 2 blank. And then we're going to fill in the 2 A's. So we got 5 here and 5 there, 7 there for our C. And B term was 9. So let's put our 9 in there. So it's -9 plus or minus. So 81. Okay, now I'm going to need a calculator for this. All right, so 20 times, okay, 20 times 7, okay, is 140. And then this was 81. All right, I'm going to show you just to make sure you understand what's going on here. Second mode clear. All right, so we have 9 squared equals 81, and 4 times 5 times 7 equals 140. So now we got to subtract. Now look, if you'll notice, this is a negative this is going to wind up being a negative. So that means our answer is going to be complex. It's going to have an I in it. Okay, so watch out for that. Be careful, and we'll go from there. So 81 minus 40 is -59. All right. So I'm sorry. Yeah. Is that right? Yep. Okay. So now divide by 10. And so if you were to look at this, it would be -9 over 10 plus or minus. Then you do this right here, the square root of 59 over 10, or -59 over 10. So the answer is going to be something crazy right here, okay? Plus or minus the square root of -59 over 10. Crazy, crazy problem. All right, so we've got -9 plus or minus. Now watch this. This is going to be I times the square root of 59. You can keep it like that in that format if you want, and then be done with it. I just don't want you to think that I is underneath the radical. That's why I didn't put it over here. You could have put I here since this is kind of a constant right there, but that would be confusing because you would think that I might accidentally be under the radical. So that's why I pulled it out front. So now our two answers are x equals -9 plus I square root of 59 over 10. And then the other one is x equals -9 minus I square root of 50, I'm sorry, I'm not supposed to put the negative there. I'm not supposed to put the negative there. I'm making all kinds of mistakes today. Once you pull out the negative, the square root of -1, that actually is positive there. And as far as I know, 59 cannot be reduced. I don't think. I mean, I think you consider 59 being a prime. See, 59 divided by 3 is that. 59 divided by 7 is that. If I divide by all the primes, it never turns out to be a neat little number. Right? So it stays 59 under the radical. And so my two answers are here and here. Right? Now we're not even through with the first page yet. All right, we got to get to this other section here where we use x equals negative blank plus or minus the square root of blank square minus 4 blank blank all over 2 blank. Okay, and so now we're going to fill in the A's, B's, and C's. Our A's go down here. Our A's go here. Our C goes here, -7. And then our B goes -5 here, -5 there. All right, now we're solving the equation. See that this is the reason why we're using the quadratic formula, because I mean, if you were to try to come up with these answers down here by factoring, it would take you, it would take you just as long to get there. You might as well use the formula to help you, okay? All right, so this is +5 plus or minus the square root of 25 plus 28 times 2 is 56. All right, so that's second mode clear. 4 times 2 times 7 is 56. Okay, 4 times 2 times 7 is 56. So that's 25 plus 56. And 25 plus 56 is 81. So that's a perfect square. This is going to turn out to be really nice here. 5 plus or minus the square root of 81 over 4. And then x equals 5 plus or minus 9 over 4. So in other words, my two answers are x equals 5 plus 9 over 4 and x equals 5 minus 9 over 4. Or this is 14 over 4 or 7 over 2. And this is negative 4 over 4, so that's negative 1. Okay, so that was a lot of work to get to the answers. The answer's 7 over 2 and negative 1. That's where it crosses on the x-axis. So at negative 1, and then 7 over 2 is 3.5. 1, 2, 3, 4. At 7 over 2, the dot would be here, and the dot would be there. This goes in a upward form because the a is positive. This a right here is positive, so it goes up. So this is where it crosses. This is the roots, the solutions, the zeros. That's what you call them. All right, so there's two solutions there, okay? Now, oh, and by the way, remember yesterday when we talked about that chart, if the discriminant is a perfect square like this, then you have two solutions and they are rational. So rational means they can be formed into a fraction, all right? If you have a discriminant here that is not a perfect square, you have two solutions, but they are irrational, okay? In other words, an irrational means like square root of 2, which, let me show you what the square root of 2 is. This is what an irrational number looks like. All right, so now the calculator can't keep going, but I mean, I could make it go out to a bunch of different digits, but if you'll notice, there's no pattern here. It's 1, 4, 1, 4, 2, 1, 3, 5, 6, 2. There's no pattern there, okay? And then another irrational number that I like to talk about all the time is pi. So I'm going to put pi in there. And if you'll look, you got another one. It's 3.14159265. So there's no pattern there, and it keeps going forever, and that's what makes it irrational. And that's what happens here when you have the square root of 59 involved. The square root of 59 is also irrational. Okay, so you see there's no pattern for the square root of 59 there. All right. All right. So let's go to the next page. All right, so let's look at this page here. So we got 6.7, 290. So we're going to solve by using square roots. This is pretty straightforward, not much to this. All you have to do is solve for x on both sides, or x squared, I'm sorry. So what we can do is add 7 here, add 7 here. So we have 3x squared equals negative 21. And so now I need to divide both sides by 3. Okay, so I divided both sides by 3. And at this point, I need to square root both sides, which notice that there's a negative sign underneath there. This is plus or minus, so put your plus or minus symbol there. I'm going to change your pens because this is kind of looking bad here. Okay, so we've got x equals, now my solution here will be two solutions. It's going to be plus or minus. Now this right here is negative 7 is negative 1 times 7. So it's going to be I square root of 7, like that, okay? So this is a complex number. Actually, it's two complex numbers because you've got a plus or minus symbol here. So my solutions are x equals I square root of 7 and x equals negative I square root of 7 because of that minus symbol right there. So there it is. Okay, so that's my solution to this quadratic here using square roots. Now you could have easily done this by the quadratic formula, but if you'll notice, there's no b term, no bx term. So that means your b would be 0. And so if your b is 0, you can use the square roots form very easily. Now over here, it's a little bit different. It's set up as a square here and a square there. Well, let's square root. Okay, first off, let's square root this right here. So we'll square root here and square root here. Remember to put the plus or minus on the right-hand side. Now that square cancels that square root, and we have x minus 2 equals plus or minus the square root of 16 is 4. All right, and so we're going to add 2 to both sides. So x equals 2 plus or minus 4. So my final answer is x equals 2 plus 4 and x equals 2 minus 4. So x equals 6 and x equals negative 2. So there's your 2 answers there, okay? All right, that's how that works out. All right, we're going to keep moving on. Give you a second to kind of catch up to where we're at here. Now, what we just did is using the square root symbol. So let's go through the fact we did grouping. Remember? And then we did factoring. And then we did quadratic equation. And now we did square roots. So we've done 4 different versions of solving, okay? And now we're going to get to another part we have not gotten to yet. So let's go through this the best we can. So let's talk about the different parts of a quadratic equation. Now we can fill this whole table out pretty quickly. These two start right here. So I can tell you right now, okay, so I'm not seeing anything at this point that's super helpful. Okay, so we're going to look at the value of the discriminant. So we're going to talk about putting in b squared minus 4ac. That's part of the little quadratic equation there. All right, and so b is 20. A is 4. That's this 4 right here, okay? 20 and 4, and then C is 25. Now, I could not reduce this. I could not divide this by anything because 4 and 25 have nothing in common. So the discriminant is 400 minus 400. So it's basically going to be 0. I'm going to show that to you. So the discriminant is going to be second mode clear. So if you do 20 squared, you get 400. All right. And then if you do 4 times 4 times 25, you get 400. So if you subtract those two, you get 0. And when your discriminant is 0, that means you neither add nor subtract a square root. So if you add or subtract the square root of 0, there's no point, right? So if you take a number and you add or subtract to it, then you'd wind up with 2 solutions. But in this case, you only have 1 solution. Check. All right. So when it's 0, you have 1 solution. Now, if the discriminant is a perfect square, then obviously it's going to be real and it's going to be rational, right? Because you can put it in terms of a fraction. In terms of a fraction. All right, so you can put your answers in fraction form. All right, so now let's go over here to the other side. So when your discriminant is 0, you have 1 solution. Let's talk about this discriminant here. So we got b squared minus 4ac. So we're going to put parentheses square minus 4 blank blank. And see what that's equal to. So our a is 1, our b is negative 2, and our c is negative 2, right? So we have 4 plus 8. So that's going to be 12. Now at this point we have a discriminant that's not a perfect square. So we're going to have 2 solutions. So in other words, we're going to add or subtract the square root of 12 here. But we have 2 solutions, but there's nothing. 12 turns out to be, you know, it's 4 times 3 like that. And then the square root of 4 is 2. So 12 is really just that. And that's irrational. The square root of 3 is irrational. Anytime you have the square root of a prime number, it's irrational. So you're going to have an irrational answer, and it's going to be real, obviously, and you have 2 solutions, all right? So when your discriminant is not a perfect square, you have 2 solutions. They're real and irrational, okay? When you have 0, you have 1 solution, a discriminant of 0. You have 1 solution, real and rational. All right, let's go over here to the next part. All right, these 2 here. So we've got, we're going to find the value of the discriminant here. So it's b squared minus 4ac. So that's going to be blank square minus 4 blank blank. All right, so we have a is 1, b is 2, and c is -3. So that's going to be 4 plus 12 or 16. That's perfect square, right? So you're going to have 2 solutions. The perfect square of 16 means you're going to add or subtract 4 to both sides, and that is rational. So your answer is going to be rational and real, and you're going to have 2 values there because this is a perfect square. All right, the discriminant of the next one is b squared minus 4ac blank square minus 4 blank blank. All right, so we're going to put 1 for A, 2 for B, and 5 for C. So that's going to be 4 minus 20. That's negative 16. So that's going to be plus or minus the square root of negative 16. And in other words, it's going to be plus or minus the square root, or plus or minus I, 4i, because I is negative, the square root of -1. I is equal to the square root of -1, right? So that's why that I is there. So this would be imaginary. So you're going to have a complex, but to be honest, real. I'm going to call it real. All right. I would be. This was optional. Okay. You can put that there. You could say it's real or not real, imaginary or whatever. But I'm going to leave that as. I want to check that as real. I may be proven wrong, but hey, it's going to take a lot for them to prove me wrong. I'm not so hard-headed. I won't admit that this could be imaginary, but I've been told by enough people that complex numbers actually are real. Okay, so all right, so let's go to the next part here. Let's see if we can straighten this up. So we're on 6.7, 291. I think it's like page 52 or something like that. I'm not sure out of that print off. But we're going to go through solving by any method that we want here. Okay. So this is going to be the last thing we do because it's probably going to take most of the time to do this. Now, if you're logically, if this were the ACT, you would need to take only 1 minute per problem. Okay. So what I usually do in that situation is I try to look at this as a broad overview, and I'm going to think, okay, what am I going to do to answer the problem that I know the fastest? And I'm going to start here. Even though it says A, I'm going to start here, and we're going to use the square root method. The reason I'm going to use the square root method here is because I've got x minus 4 squared equals 17, and we're going to square root both sides just like that. What I'm trying to do is solve for x, and so I get x minus 4 equals plus or minus the square root of 17. That is irrational. So x equals 4 plus or minus the square root of 17, and the answer is done. Done. That took less than a minute, right? Okay, so you do what you know what you can do here. So the answer is x equals 4 plus the square root of 17 and x equals 4 minus the square root of 17. So you do what you can do within a minute, all right? Try not to take any longer than you have to on here. My mind is gravitating towards this one now. All right, we're going to do this one by, I'll tell you what, I'm thinking factoring on one of these two. I'm not sure which one I'm going to deal with yet. So let's see what we can focus in on, which ones can be factored, okay? Let's do both by factoring and see which one factors out. If one of these factors out, we can get the answer and move on, all right? This is 1 times 1, 1 times 1. 1 plus 1 does not make 1. 1 minus 1 does not make 1, so it can't be done by factoring. So we know we can't answer this question. We're going to go over here, all right? So we've got 2 and 1. Obviously, this symbol means they're going to have the different signs. And the largest one is going to be positive. So the largest number is positive and the smallest number is negative. So when I take 2x and I take away 1x, I get positive 1x when I multiply that. So we've been able to do this by factoring. So we set that equal to 0. Or remember, the answer is negative 2 over 1 and positive 1 over 1. All right? So if you can do it that fast, that's within 30 seconds, right? So we're going to set x plus 2 equals 0 and set x minus 1 equals 0. So we're going to say x equals negative 2 and x equals 1. Okay, so those are my two solutions there by factoring. That's square root method and factoring. One of these two right here are going to have to be done by the quadratic formula. All right. Now notice that neither one of these are done by grouping. So we'll do one of these by the quadratic formula, and the other could try completing the square. You know what? Let's try completing the square on this one here. Okay, let's try completing the square just to refresh you. Okay, when you hear the words completing the square, remember the terms b over 2 squared. These two need to be synonymous in your mind. So what we're going to do is we're going to move the c term over to the other side, and then we're going to take this b term and we're going to add 1/2 squared to both sides. Okay, just like that. So this is called completing the square. And so when you complete the square, you end up with the square root method here, okay? And so, okay, so let's do, now remember your completing the square method is going to take a little bit more brain power here, because this b term right here, this b over 2 term, is the term that goes right here. So that's why I drew that arrow right there. Okay, so because 1/2 squared is 1/2 squared, and x squared is x squared, and when you add 1/2 and 1/2 together, you get 1. All right, that's what that means. And so now this is 1 minus 1, negative 1 plus 1/4. That's what that is, because 1 squared is 1 and 2 squared is 4. All right, and so now I'm going to rewrite this, make it nice and neat before I move into the next section. So this is $1 take away 25 cents, so that's going to be a negative 3/4. So in other words, now we need to solve both sides by square root method. And so I have x plus 1/2 equals the plus or minus I. Now watch this. It's going to be square root of 3 over 2. You see that? So look right here. So if I took out that negative square root right there, that's going to be I. And then you have the square root of 3 on top and the square root of 4 on bottom, but the square root of 4 on bottom is 2, right? So notice now that we have a common denominator here, okay? And so when we subtract 1/2 plus or minus I square root of 3 over 2, you can combine these right here by using the common denominator and make it negative 1 plus or minus I square root of 3. And so your two answers would be x equals -1 plus I squared of 3 over 2 and x minus 1 minus I squared of 3 over 2. Okay, and so there's your two answers, bam, right there. All right. Now, that was a lot of work. I was just trying to show you that completing the square is an option here. We could have done that by the quadratic formula, which we're going to do right now. I'm going to go ahead and work out the quadratic formula down here, and this will be the last thing we do. X equals -b plus or minus the square root of b squared minus 4. And see, remember, you can do this all for every single one of these. You can do the same quadratic formula. It's just sometimes it's a little more work than it needs to be. Like these first two, I got these very easily. This is simple stuff to remember. Now we've got to go in and make sure our symbols are all right. X equals negative blank plus or minus the square root of blank squared minus 4 blank blank. There's your discriminant. Remember that? All over 2 blank. Okay. So now we're going to put in our b term, which is 11 here and 11 here. Our a term was 6, and our c term was 3. So it's -11 plus or minus the square root of 121 minus 12 times 6 is 72. And then 121 take away 72. 121 take away 72 is 49. That's a perfect square. Square root of 49 is 7. See that? So it's a perfect square. We're going to have a rational answer at the bottom. So x equals, all right. Okay, so down here we're going to have -11 plus or minus the square root of 49 all over 12. So that turns out to be -11 plus or minus 7 all over 12. So that means our answers are -11 plus 7 over 12 and x equals -11 minus 7 over 12. And so now this means x equals 5 over 12, -5 over 12. And x equals -18 over 12, which means x equals okay, so this is divisible by 6, so that's 3 over 2. Okay, so there's your two answers. Done. All right, so we're going to wrap it up right there today. If there's any questions, type them in the chat before we leave, before this time runs out. We've got about a minute left. Does anybody have any questions over the 4 ways to solve these problems? Now, the one thing we did not, I'm not even going to cover this back here. You see that? It says by completing the square. I'm not even going to cover that. So we're done reviewing. So that basically all you needed was this one page right here, the whole day. We went through all that to say that this one page, if you know how to do each one of these 4 here, you're good. All right. So we're moving on to the next section, which is going to be chapter 7 tomorrow. So I'll print off 7-1 and go from there. All right, we'll see you tomorrow.